stem. The stem, which connects the actuator and disc, is responsible for positioning the disc. Stems are typically forged and connected to the disc by threaded or welded joints. For valve designs requiring stem packing or sealing to prevent leakage, a fine surface finish of the stem in the area of the seal is necessary. Typically, a stem is not considered a pressure boundary part. Connection of the disc to the stem can allow some rocking or rotation to ease the positioning of the disc on the seat. Alternately, the stem may be flexible enough to let the disc position itself against the seat. However, constant fluttering or rotation of a flexible or loosely connected disc can destroy the disc and/or its connection to the stem. The two common types of valve stems are rising stems and non-rising stems. These two types of stems are easily distinguished by observation. For a rising stem valve, the stem will rise above the actuator as the valve is opened. This occurs because the stem is threaded and mated with the bushing threads of a yoke that is an integral part of or is mounted to the bonnet. So we can see here that we have a rising and non-rising type of valve. Here is the non-rising type, and here is the rising. The thing that you will notice is that as the valve is opened on this diagram here, the stem pops out the top. So you can watch it, it's coming out the top, and up there. That is a rising stem gate valve or a rising stem. It's very useful because you can actually see the position of the valve from a way off. So if you're walking around the plant and you want to check the position of certain valves, this is going to be a way to easily do that. You can just quickly look and you'll notice if the stem is raised or lowered, and then you'll know if the valve is open or closed. Let's have a look now at the non-rising type. We can see here the non-rising type is moving upwards, it's moving to the open position, but there is no stem popping out of the top. What's actually happening here, you can't actually see it, but on the top we have here a straight connection from the stem to the main gate or the disc, and it is more or less pulling the gate disc or the disc upwards. With the non-rising type, this isn't happening. What we're actually doing is we are screwing the stem into the disc, and then we are jacking up or screwing up the disc. So that's how it functions. There is no upward stem movement from outside the valve for a non-rising stem design. For the non-rising stem design, the valve disc is threaded internally and mates with the stem threads. So as I said here, we can fix the stem directly to the valve, and then we can raise it directly upwards. And in this one here, we will actually screw into the disc, and that will pull our disc upwards. So let's just recap. We can see that the one here is raising the stem, and we have a yoke, which is this device on the top of the bonnet, and the yoke is essentially pulling our disc upwards. On the non-rising type, we do not have a yoke. What we're actually doing is screwing the stem more and more into the valve in order that we can open the valve and lift the disc. So two slightly different designs there, but they are referred to as the rising and non-rising stem types.